Welcome. In this explainer, we're going to break down one of the most fundamental topics for your SPM chemistry paper, ionic bonds. Get ready to really master the concepts, tackle those exam questions, and lock in those marks. But before we jump in, a quick tip. The best way to make these concepts actually stick is to practice them. So after we're done here, I highly recommend you test your knowledge with some real SPM questions. You can just scan the QR code on your screen to download the MCQ SPM app or visit the website. All right, here's our game plan for totally mastering ionic bonds. First, we're going to nail down the core definition. Then we'll look at exactly how to identify these compounds in exam questions. And finally, we'll walk through a kind of tricky calculation from a past paper, just to make sure you are 100% prepared. So what's the most important thing to remember? Well, an ionic bond is all about one word: transfer. A metal atom gives away an electron, and a nonmetal atom accepts it. That's it. It's a simple, permanent give and take.
You can think of it like a story in 5 acts. So you've got a metal atom, like sodium, and it wants to get rid of its single outer electron to become stable. On the other side, you've got a nonmetal, like chlorine, who is just desperate to gain one more electron to complete its outer shell. So the electron makes the jump. This creates 2 charged particles, or ions. And because opposites attract, they're pulled together by this really powerful electrostatic force. And boom, you've got yourself an ionic bond.
Let's lock in these terms because you are going to see them everywhere. The metal atom that loses an electron becomes positively charged. That's a cation. You can remember this by thinking a cat has paws, and cations are positive. Cheesy, I know, but it works. The nonmetal that gains an electron becomes negative. That's an anion. And here we have it, the most famous ionic couple in all of chemistry: sodium and chlorine. Sodium gives away its electron, becoming the positive Na+ cation. Chlorine eagerly accepts it, becoming the negative Cl- anion. This attraction is what forms sodium chloride, which you probably just know as, well, table salt. Okay, so now that we get the what, let's really focus on the how. How does this concept actually show up in your SPM paper? See, examiners love to test your ability to identify these compounds and describe their pretty unique properties. So, how do you spot one of these in an exam? Well, there are 2 main ways examiners are going to test you. They'll either ask you to pair up elements that will form an ionic bond, or they'll describe a substance's properties and make you identify it from that description. Here are your dead giveaways. The number 1 clue for sure is a metal reacting with a nonmetal. Just think about elements from the far left of the periodic table, like group 1 or 2, meeting up with elements from the far right, like group 16 or 17. Sodium and oxygen? Yep. Metal and nonmetal. Magnesium and chlorine? You got it. Metal and nonmetal. These are your classic ionic pairings. Now, this next part is absolutely crucial. It's the key to answering a huge number of exam questions. You really need to memorize these 3 properties. Ionic compounds have super high melting points because that electrostatic force we talked about is incredibly strong. It takes a ton of heat energy to break those ions apart. And why do they only conduct electricity when melted or dissolved? Well, because the ions have to be free and mobile to carry a current. In a solid, they're just locked in place, not going anywhere. All right, let's talk about the common traps. So many students trip up on these simple points and lose easy marks. We're going to make sure you are not one of them. This is the number 1 mistake I see, year after year. The examiner asks, does sodium chloride conduct electricity? And the answer is, well, it depends. A solid block of salt? Nope, the ions are stuck. But if you dissolve it in water or melt it into a liquid, yes, the ions are now free to move around and carry a charge. Always remember, mobile ions are the key. The second big trap is predicting the chemical formula. It's all about balancing the charge. A classic question, like one from a past paper, pH2019A48, gives you an element W with an electron arrangement of 2.8.2. So it's going to lose 2 electrons to form a W2+ ion. Then it gives you element X, which is 2.8.7. It wants to gain 1 electron to form an X- ion. So, to balance a +2 charge, how many -1 charges do you need? 2, right? So the formula just has to be WX2. Okay, time for the masterclass. Let's tackle a calculation-based question. Now, these can look kind of scary, but I promise, once you know the steps, they're actually pretty straightforward marks. We'll use a real example to prove it.
Here it is, straight from the PRL 2017 A35 paper. You're given a formula, a mass, and the relative atomic masses. The goal is to find the actual number of T ions. Okay, don't panic. It's just a 4-step process.
Let's break it down. Step 1. Find the total molar mass of E2T3. That's 2 E's and 3 T's, which adds up nicely to 102. Step 2. Find the moles of the compound you have using that classic formula, mass over molar mass. So 10.2 divided by 102 gives us 0.1 moles. Now for step 3, and this is the really important part. Look at the formula, E2T3. This tells you that for every 1 unit of the compound, there are 3 T ions. So we simply multiply our moles of the compound by 3. That's 0.1 times 3, which gives us 0.3 moles of T ions. Finally, to get the actual number of ions, we just multiply the moles of ions by Avogadro's constant.
And that gives us our final answer, 1.8 times 10 to the power of 23. See? By following those steps, you can solve any question just like this one.
Okay, we have definitely covered a lot, so let's just distill all of this down to the absolute essentials you need to walk away with for your exam. Here is your exam cheat sheet. Number 1, an ionic bond is about the complete transfer of electrons. Got it? 2, they have high melting points and only conduct electricity when their ions are mobile, which means molten or dissolved in water. And 3, for calculations, the pathway is always mass to moles to the ion ratio, and then finally to Avogadro's constant. If you can just remember these 3 things, you're going to be in a great position.
And that wraps up our deep dive into ionic bonds. Before you go, I'll leave you with a question to think about. We've mastered what happens when electrons are transferred, but what type of bond forms when they are shared instead? We'll tackle that one next time. Thanks for joining me, and I'll see you in the next explainer.